Okay, so remember what we did last class. So these are formulas, the definitions of the sine, the cosine, the tangent, the cotangent, using the unit circle as reference, correct? So these definitions are from the right triangle trigonometry, and we just adapt this to the circle. And then depending on the x and y values, we have for angles more than 90 degrees. Then from the same trigonometric identities, the definitions, we determine the first identities. These are extremely important. You have to remember that the cosine and the cosecant and the cosine and the secant, the sine and the cosecant are reciprocals, and also that the tangent is the sine divided by the cosine. So this is very important to simplify expressions, okay? So this is something you have to remember. Then remember, in some situations, we remember the even odd function, so reflection respect the x-axis, right? The y-axis. So sine of the negative angle is negative the sine of the positive angle. The cosine of the negative angle is the same as the cosine of the positive angle. Tangent of the negative is negative the tangent of the positive, and so on, the reciprocals, right? Other identity we did last week is the shift. If you shift pi over 2 sine, you get the cosine. If you shift pi over 2 sine, cosine, you get the sine. If you shift pi over 2 the tangent, you get the cotangent, and the same with the other functions. So these are periodic, so you can pretty much find one from the other one, just shifting the function. Then these are the first Pythagorean identity. The equation of the circle center at the origin is x squared plus y squared equals r squared. Then the unit circle means that the radius is 1. Now, these are the components in the unit circle we did before. X is the cosine, y is the sine. If we substitute these two, we get sine squared plus cosine squared equals 1. So this is the first important identity we have to use involving powers. Sine squared plus cosine squared equals 1, right? And from this one, we have two more. Secant squared minus tangent squared and cosecant squared minus cotangent squared also equals 1. So everything begins with this one. This is the primary. From this, we can get these two. It's very simple. So if you have, for instance, sine squared plus cosine squared equals 1, then suppose we multiply everything times the reciprocal of the cosine. So cosine of the angle. So you can do this because if you multiply an equation by the same number, the equation is the same. So you have, let me just put cosine squared. So if you multiply this times this, you get sine squared over cosine squared of the angle plus cosine squared over cosine squared of the angle, 1 over cosine squared of the angle. So if you multiply this equation, you get this one. Now, use what you know. This is 1, cosine squared over cosine squared. This is a 1, correct? So this is plus 1. Then remember the identities I told you. So 1 over cosine is the secant. So 1 over cosine squared is the secant squared. So this is secant squared. Then you have sine over cosine. Again, what is sine over cosine? The tangent. Sine squared over cosine squared is the tangent squared. So it's tangent squared of the angle. Then what you have to do is just move this to the side, and you have secant squared minus tangent squared equals 1. You see it? So from this identity, using some manipulations, you get another identity. So the identity you have always to remember is the first one. Sine squared plus cosine squared equals 1. This is fundamental. As the one, sine over cosine is tangent, and so on, correct? So from this, we get this one, secant squared minus tangent squared, and then cosecant squared minus cotangent squared. You get the same, just you divide this first one by the sine, and then you get the second one, cosecant squared minus cotangent squared equals 1. Okay? So this is the formulas we're going to use to prove identities. Okay, now, formula booklet, right here. Formula booklet. Remember, you have this formula booklet with you. If you don't, I upload this in Google Classroom. So you go over there and download it and print it. But here are the identities we have to use. You have here the definition of tangent, sine over cosine, and all those things. Here, the unit circle. Here, the graphs of the trigonometric functions. And here, this with the negative angles when you shift pi over 2. And in the next page, because it was impossible to fit it right here, you have the 3 I showed you now. In next classes, we're going to prove the next ones. So these next here in the same section, right, are going to be extremely important. But by now, we are going to work with the Pythagorean, this one, the Pythagorean relationships, okay? So remember, for this section, you need this next to you. Of course, there are more identities. I just include most of them right here. So there are many ways to get cosine and relate them. So these are just information. Usually we use this and there was in the previous page, these ones right here. Okay, so let's go to the assignment now. I'm going to show you this one, okay? We have to prove these identities. Let's begin with the first one. You have cosine x plus sine x times tangent x equals secant x, okay? So I'm going to prove the first one. So you have to prove that if you combine this function, you get the secant. So if you put this in the calculator and you graph it, and then you graph this one, you see the same line. But you have to prove that they are the same, not with the calculator, algebraically. So what you have to use? The identities you know, correct? So cosine cannot be broken, sine cannot be broken, so these are your primary blocks. But tangent can. So let's see. Suppose you this, okay, this cosine of x plus sine x, and tangent is sine over cosine, correct? So you change the tangent by sine over cosine. Is what you know. Tangent is sine over cosine. Okay. Now you have this fraction and you have this number. So I'm going to do this. Cosine x plus sine times sine is sine square of x over cosine x, right? Remember, I'm going to go from one part of the identity and I'm trying to find this side here. Okay, now how do you do the fraction? Remember your fractions. So you have 3 plus 4/5. So you have to put here 3 times 5 over 5 plus 4 over 5. And then you do 3 times 5 plus 4 over 5. Everybody knows those fractions, correct? Okay, so I'm going to do the same. Remember, these are numbers, so they follow the same rules. So I have cosine square x over cosine x plus sine square x over cosine x, right? So you make this a fraction with the same denominator, so you multiply this, let me just put it right here, over 1. You multiply times cosine, you get this one right here, okay? What is the next one? Oh, the next one is put it together. So this is going to be line cosine x, and then you have cosine square x plus sine square x, right? Now, at the top, you have your primary Pythagorean relationship. You know that sine squared plus cosine squared is 1. Is what you know. Cosine squared plus sine squared is also 1. So this is going to be equals 1 over cosine x. But what is 1 over cosine x? 1 over cosine x is secant. So this is secant x. Everybody? So check what I did. You begin with the longest and more unfriendly expression, this one. Then you try to break some of the functions here with other identities, in this case, tangent sine x over cosine x. Once you have that one, you use your algebra. This fraction, right, is here, And then you are going to add these two as fractions, so your denominator is 1. So you make a common denominator, multiply these two by cosine. You get cosine squared over x, then you put the common denominator, then you have the top, and then you see that this is 1. 1 over cosine x by definition is secant x. So you prove the identity. So this is the situation. From one side of the identity, you try to find the other side using identities, other identities, and algebraic manipulations, correct? It's not that difficult. Any question here before we move on to the next example? It's pretty simple. Okay, let me just see the next problem. Okay, right here. So you have number 2. So you have sine squared. Let me just put it right here. So you have sine squared alpha minus sine to the 4 alpha equals cosine squared alpha minus cosine to the 4 alpha, correct? Okay, let me just go to my board. Here is my identity I have to prove. So I have to choose, go from left to right or from right to left. So begin here, end here, or begin here and end here. So, well, this is not a problem. I just begin left to right, correct? So I have sine squared, sine to the 4, correct? Well, let's see. Sine squared is here, and sine to the 4 is sine squared. So I'm going to do my algebra. Sine squared x, or alpha, minus sine squared alpha times sine squared alpha. So everybody knows this, right? Because you have a to the 4, this is a squared times a squared. You know that from algebra 1. So what I did is this 4 is 2 squares. So I put these 2 squares, right? Now, if you have a common factor right here, you can factor the common. So I have sine squared and sine squared. The sine squared times 1, right? This is 1 times sine squared. So I'm going to take sine squared of alpha, parentheses, 1 minus sine squared of alpha, right? So it's the same as you do. This is okay. I have AB plus AC. So this is AB plus C, correct? I'm doing my algebra 1. Okay, now, 1 minus sine squared. Well, you have to remember, precalculus. Sine squared plus cosine squared is 1. So 1 minus sine squared, or you put this one, cosine squared equals 1 minus sine squared. How do you get this one? So you just move the sine to the other side, correct? Sine squared plus cosine squared is 1, so cosine squared is 1 minus sine squared. So you move this to the other side. Now, you are going to see that this is okay. This is cosine squared, okay? Very good. So this is sine squared times cosine squared, correct? So you change this by this using this. But if you change this one, cosine squared over 1 minus sine squared, also sine squared is 1 minus cosine squared. Everybody see that? So from this identity, you get any of these two. Cosine squared equals 1 minus sine squared is sine squared 1 minus cosine squared. So now I'm going to use this one right here. Sine squared is 1 minus cosine squared. So I have 1 minus cosine squared alpha times cosine squared alpha. Now, this parenthesis is pretty much the reverse of this one. So I'm going to distribute now these two. So I have cosine squared alpha minus cosine squared alpha times cosine squared alpha, correct? So I multiply both terms by cosine squared. And then I remember that a squared times a squared is a to the 4. So this is cosine squared alpha minus cosine to the 4 alpha. And this is what you want to prove, that this expression is this one. So remember, I began, this is equal, 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 equal. So it's an identity. That's the mean of identity, is the same. You see? Okay. So check what are the tools in this side in different color. Basic algebra and other trigonometric identities that I combine with the things I have, and I do more algebra, okay? Everybody? No questions? Okay, let's move to the next example. We have now a quotient, this thing. So I have, right here. This one, okay? So I have a quotient now. Oh, these are really, really tough, okay? So I have secant of the angle minus 1 over 1 minus cosine of the angle, and this has to be secant of the angle. Okay, let me just stop right here. Let me just take this one. Delete. And then right here. There it is. Okay, this is what I have to prove now. Secant of theta minus 1 over 1 minus cosine theta equals secant theta. Okay, now, obviously, in this, there is no choice. We're going to begin from left to right. So we are going to try to reduce this fraction into this one, right? So, but it seems that there is no way out. It's okay, well, I have cosine, but remember, my primary blocks are sine and cosine. So I have to remember, okay, my formulas. Let me see my formulas. Secant is right here. Secant is 1 over cosine, you see? Or cosine is 1 over secant. So you have two possibilities. Change the cosine 1 over secant, or change the secant 1 over cosine. What do you want to do? You have to choose. Cosine changed by 1 over secant, or secant 1 over cosine. Check what you have to find. Secant, correct? So possibly the good idea is change cosine by secant, correct? Because I want to find secants. So let's do that. So I'm going to put here secant of the angle minus 1 over 1 minus 1 over secant of the angle, right? Like that. Okay, now what I do with this one? Okay, let me just remember what happened in a problem like this. 3 minus 1 over 1 minus 1/3, for instance, something like that. How do you solve this one? Okay, I have to do the fraction at the bottom first. Okay, so I have here 3 minus 1 over, I'm going to make this a fraction, so this is 3 over 3. Everybody knows that 1 is 3 over 3, minus 1 over 3, correct? Then I have to combine this in a 1, 3 minus 1 over 3 minus 1 over 3. Then, I'm not going to do the numbers, I make the top a fraction. 3 minus 1 over 1 over 3 minus 1 over 3. Correct? I'm doing algebra 1. So, now you have a fraction divided by a fraction, so what you have to do is the sandwich rule. These two, so I have 3 times 3 minus 1 over 1 times 3 minus 1, correct? And then what you do is just 3 minus 1 is the same thing. I simplify, and then get 3 over 1. So everybody's catching what I did here in fractions? Because you are going to do exactly the same here. So if this is not mastered, this is going to be difficult, okay? So no problems here. The part in green is okay? Perfect. So let's do the same here. So I have secant of the angle minus 1 over secant of the angle theta, secant of theta minus 1 over secant theta, correct? So I'm doing exactly the first step right here. So I put this a fraction right here, same. Now this is going to be secant theta minus 1 over secant theta minus 1 over secant theta. So I put this together as I did here, right? This like this. Okay, what is next? Okay, next I have to make this a fraction. So this is secant theta minus 1 over 1 over secant theta minus 1 over secant theta. Now I'm here, a fraction over a fraction. You see? I have a fraction over a fraction. So I have to do the sandwich rule. Okay, sandwich rule. I multiply these two, and I put the product at the top, and then I multiply the mid's, and I put it at the bottom. So this is secant theta minus 1 times secant theta over secant theta minus 1 times 1. What you can simplify exactly right here, you simplify this parenthesis so you cancel out, and then you have secant theta over 1, secant theta. Okay? Very difficult. Just I don't want you to miss something. This secant of the angle is a number as this number 3. So whatever you do with these green numbers, you can do it with this same expression, correct? It's very important. Don't be scared of this expression, because at the end, these are numbers like these ones. And if you remember how to do these fractions, you remember these fractions, okay? You can solve these ones. Okay, questions? Any point that is not clear here before we move to the next one? Stephanie? No? Braulio, Jana? No? Tony? Okay. Has smart students only. I know that. Okay. So let me see what happened in the next problem. Let me just go to the next problem. Okay. Number 4, now this problem, yeah, this looks kind of weird, right? You see this problem? Okay. Now you have more expressions that, oh my gosh, this is scary. Let me see. Sine to the 1/2 x cosine x times minus sine to the 5/2 x cosine x has to be cosine cube of x square root of sine x. This is, oh my God. Almost a heart attack, correct? You see this is, oh my God, no, 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 I'm not going to graduate. This is impossible. I cannot do this. No, you can. Because it's the same as Halloween. Kids dress as werewolf and Dracula, but they are kids, and you're not going to be scared of kids. So let me see now my algebra here. Okay, let me just remember some algebra. So this is a to the 1/2 stands for square root of 8, correct? Yeah. A to the 5/2 stands by the square root of a to the 5th, correct? It's the same. Now, how can you simplify this one? This is okay. This is, let me just put it right here. This is the square root of a, let me just put here, a to the 4th times a to the 1. You remember that a to the 4th times a to the 1 is a to the 5th. So you can break this like this. So this is going to be simply the square root of a to the 4th times the square root of a. Now, what is the square root of a to the 4th? Well, a squared. because a squared times a squared is a to the 4, the square root of a. So everybody understand this algebra? These exponents, radicals. You cover these radicals in algebra too, okay? Well, now I'm going to use this notation right here, exactly right here. So I'm going to begin from this complex and I'm going to try to find the last one. So I'm going to write, okay, everybody ready? So I have the square root of sine x times cosine x minus this sine phi over 2 is going to be written like this one. So it's sine square x times the square root of sine x. You see, I'm doing the same expression, this, and times cosine x. Okay, so what I did, I put these ones as radicals, these ones, and that is going to give me a much better vision of what to do. Let me see. I have here sine x cosine x. I have here the square root of sine x cosine x, a square root of sine x cosine x. And what I'm going to do is remember my basic algebra. A plus AB is A times 1 minus B. 1, A parenthesis 1 minus B. Correct? Algebra 1, I'm going to use it here because this term is exactly right here. So I'm going to factor. So I'm going to factor my thing. So it's going to be a square root of sine x times cosine x, parenthesis 1 minus sine square x. Okay, and what is 1 minus sine x? Sine square x. It's okay. Trigonometric identities. You have a sine square, so you have to think in this one, right? You have here that sine squared plus cosine squared equals 1. So cosine squared is 1 minus sine squared. This has to be automatic. This has to be wired in your brains, okay? Now, I'm going to change this by this. So this is going to be a square root of sine x times cosine x times cosine square x. Now, what is this? This is cosine cube, correct? So you're going to have that this is equals right here is going to be cosine cube of x times the square root of sine x. So you can switch the product and you get exactly what you want to prove right here, you see? So you arrive from here using some algebra, you get your identity solved. So you prove that this long thing is this one right here.
I'm confused.
A ver, where?
Like where it says after 1 minus, right where it's 1 minus sin square x. Yeah, I don't know how you got that.
It was very simple. What you have here?
Oh, cosine minus sine? Or what?
You have this one, right? So you have this times sine square. And you have this times what? That's 1. No, check. This multiplies the sine square. The same here, the same thing here multiplies what? 1. Correct? Is what I have here. A minus AB. If you factor the A, you have A times 1, A times B. Correct? Is this clear?
A little bit, yeah.
All right, this is clear. Now check that this is the A. All this is A, and it's by itself, you see? Then you have the A times this. This is the B. So A minus AB, A minus 1 is A times 1 minus B. So it's what I did. Here is a 1. With this one, there is always a 1. So this is the one I put here. If you distribute back, this times this is this, and this times this is this. Once you have that one, you use the identity, and then you get what you need. However, somebody else has a problem here. Remember, if the algebra is weak, this part, you are going to have problems here. everything relies on here, okay, with some trigonometry. Check. Green with blue is not trigonometry. This is algebra. The only trigonometry I use is this one in orange, just to change this expression into this one. Okay? No problem? Yep. This was Zamora, Toño. Okay. Okay. One more, right? And then you are going to have to begin your homework. Okay. So, well, two more. Let's just do the first page. Tomorrow, well, Thursday, we do the next ones. You check these scary things for Thursday. So today we are going to do these ones. Okay. Okay. Let me just check this one. This is so I have 5. This is tangent square of theta over secant theta equals sine theta tangent theta. Okay. So we have to prove this identity, that this quotient can be simplified into this expression. Okay, well, let's see. Remember something, I have tangent, I have secant, so, and I need sine here, so possibly I have to break this one, right, tangent, into one sine over cosine. Let's see. Okay, let's see, is right here, my identities. Tangent is sine over cosine, right? And secant is 1 over cosine, you see? Okay, let me just try this one, right? So it's okay, let me just change the tangent square over 1 over cosine. So I change secant by 1 over cosine. Okay, I keep the tangent now. Okay, now I'm going to do the sandwich rule. This is tangent square over 1 over cosine theta. So I'm using the sandwich rule. Remember, this is a fraction. I make the top a fraction. So I have a fraction over a fraction. So I'm going to do the sandwich rule. This times this at the top over this times this. So I have tangent square theta times cosine theta, correct? Okay, now I'm going to change now the tangent by sine over cosine, correct? Tangent is sine over cosine. So this is going to be tangent theta. This is tangent times tangent, so I'm going to take sine over cosine times cosine. So I split this one in tangent times tangent, tangent times tangent, and one of these tangent is going to be sine over cosine, correct? Okay, what can I do with the cosines? Well, cosine at the top, cosine at the bottom, they cancel out, and then I get the tangent theta times cosine times sine theta. That is exactly what you have here. Sine times tangent is tangent times sine. Okay? A ver, something confusing here? No? Yes?
Wait.
A ver, a question? No question?
So you put sine over cosine because
tangent is sine over cosine, correct? So I'm using identities to prove other identities. That's the game. Also,
how come you didn't get rid of tangent?
What is it?
Oh wait, never mind.
No, tangent square is tangent times tangent, correct?
Oh yeah.
So I just change 1. I keep 1 and I change 1. I cancel the cosines and I get this one. That is exactly that.
I get it.
Okay. Very good. We're going to master this very soon. Okay, last problem for today. I don't want to really exaggerate with this thing. Okay, I have this last problem number 6 right here. So I have to prove that cosecant minus sine is cosine times cotangent. So I have cosecant x minus sine x equals cosine x times cotangent x. Okay. Now, both sides looks pretty much complex, so you have to decide to go left to right or right to left. What you want to do? Begin cosecant x minus sine x or begin cosine x cotangent x? Which one? You have to make the choice anyway. What do you want? A ver, Alia. You want cosecant x minus sine x, begin there or begin in cosine cotangent?
Cosine cotangent.
Cosine cotangent? Okay.
Yeah.
You said. Okay. So let's begin with this one. This is like a cosine x times cotangent x. Okay. The reasoning is the same as you begin with this one. Cosine is a block. It's a primary block. But what is cotangent? What is cotangent? Okay, let's see. What is cotangent? Cotangent right here is cosine over sine, right?
Mm-hmm.
Okay, I'm going to use cosine over sine. So this is equals cosine x times cosine x over sine x, correct? Everybody fine? Okay. This is a fraction, and remember how you multiply a fraction. You have 3 times 2/5. You have this product. Remember that you did 3 times 2 over 5. Everybody remembers that? That's a crazy fraction, 6th grade math. So I'm going to do the same here. This is cosine squared x over sine x. Oh, I still have a fraction, right? Yeah, and I have no fractions here, so I have to break this fraction. Okay, what is cosine squared? Okay, remember, sine squared plus cosine squared is 1. So cosine squared is 1 minus sine squared, correct? This is very, very used, so you have to remember always this. Okay, I'm going to change this by this one. Okay, so this is 1 minus sine squared x over sine x. Okay, now to break the fraction, I'm going to split this in two. Remember, you have a plus b over c. This is a over c plus b over c. Well, this should be really algebra 1, so I'm going to use a different color. So this is a plus b over c is a over c plus b over c. Okay, this is algebra 1, the green one. Here I use trig. Okay, so I split this in two. So I have 1 over sine minus sine squared over sine x. Okay, now what is sine squared over sine x? Well, you have a square over this one, so let me just put it right here. So you have a squared over a, that's an a, correct? Yeah, and the other one is what? So 1 over sine is cosecant, you see? 1 over sine is cosecant. So I use cosecant equals 1 over sine, and I use that a squared over a is a. Then I have what I need. This is cosecant x minus sine x. So it's exactly what you have here at the top, cosecant x minus sine x. Okay? This part is extremely important here at the right. If you don't have this clear, when use algebra or when use trigonometry, it's going to be difficult for you to simplify expressions, okay? Okie dokie. No questions?